This is Ross Lacey, and he is with RAR UK.
Yes.
You haven't thought about renaming it RAR? Or
No, we were close. Everyone calls us RARUK, but we're RAR UK Automation.
Super. Now, we're looking here at a couple of universal robots that are working together, and these are also collaborative robots, so they work not only with each other, but with humans, right?
Yeah, so a collaborative robot's designed to be safe to use next to a person. It's quick to deploy, very, very small footprint. So a normal industrial robot palletizer will take up almost this space plus another half. So it's much more compact, very, very quick to deploy. We can deploy a system like this within about 3 weeks, so really quick. But the idea of the universal robots is that we can be used for palletizing, pick and place, visual inspection tasks. They're not limited to a specific application or industry. We've got them in every single industry and every single application.
So does this mean that they come apart and you can put different joints and different endings on them?
Not quite, no. Different end effectors.
Yep.
So they've got 8 different robots in their range, varying in different sizes and payloads, depending on the application you want to do, but very agnostic to whatever end effector you want to put on. So this could be in this case, we've got a vacuum gripper. It could be a 2-finger gripper. It could be a longer vacuum pick. It could be a screwdriver. It could be an inspection task. Very, very up to the customer really what we want to do with it. It's very flexible.
And this is the way that you handle fragile or flexible goods, isn't it, with the suction cups?
Yes, it's one of the most adaptable ones. So for different size boxes, different weight boxes. This one we've got our robotic power pick on it, so we're actually control what suction cups are on at one time, so we can have different size boxes coming down a production line without having to retool the end effector.
So they're collaborative with people. That means they've got to have a lot of sensors for those pesky people that get in the way and are unpredictable. What does that mean when you're making a robot like this?
So fundamentally, a collaborative robot is safe before it's put into an application. It depends on what type of application you're going with it. So when we're palletizing, we're effectively moving a box around head height. So in that case, we actually need to look at guarding. We need to look at safety sensors, safety scanners, just to make it so it does still comply with all safety regulations. But if you were to still get into the cell, that robot's going to hit you, it's going to stop without doing any permanent damage. So they're much lighter weight robots than an industrial robot, much quicker to install and a lot more flexible. We can move it from one position to the next, much easier depending on application regulations and how you put it in. But yeah.
If you wanted to change what this robot was doing, so you take out the suction cups and you put on a screwdriver or something like that, is it a case of training it or reprogramming it, or are there set programs that you then load in to do the new thing?
Currently, you'll be reprogramming it. It's a real straightforward programming course. Like we have a basic course, which is 2 days long for your core training course. Advanced training is 2 days. My 6-year-old has programmed this robot within about 2 hours.
Yeah, that's the thing with kids, right? Everyone's 6-year-olds can do all that stuff.
They're not scared of it. They just pick it up and do it. But yeah, you can pick a robot up, retrain it, and reteach it to do another task in the same day. It's quick, really quick to do. We're
talking about the future of work and what job kids will do when they grow up. Kids are doing them at the age 6. Yeah. You see, you're employing a load of 6-year-olds to program your robots.
Yeah, and AI is coming in now, so you're going to, next few years, you'll see, instead of having to program the robot, the whole presence is you're going to tell the robot to pick up a bottle, and it would just go and pick up the bottle without having to worry about the programming. So we're not there yet, but that's where...
This is where I've been vibe coding recently. If you're familiar with vibe coding, this is where you basically tell the computer, I want a program that does this kind of stuff. Exactly. It generates the code. So that's what you're talking about.
Yeah, exactly. So like using like your local language, the large language model to talk English to it, and it will figure out how to do the movements, how to do the precision. That's where stuff's going. We've got an AI camera on show over here, but that's very different. We've taught it a product, and then that figures out then how to pick the product with minimal amount of programming. We just tell the robot to go to a position, then the AI system tells it how to pick and how to place.
And it looks at the shape. Does it have a little fiddle with it and see whether it falls out, or does it kind of know from looking at it?
We'll teach it like through a CAD file. We'll give it a CAD file, and it will spend a few hours analysing that, work out millions of different incurations it could possibly see it in. And then with that, we just literally tell it what our tool is like, so what the end effector is, if it's a suction cup or if it's a gripper, then where we're going to pick up on the vial in this case, or on the object. And then we teach it a pose position, so where it can see it, and from that point on the software will take over and do it automatically.
We've also got this fella down here. Does it have a name, this?
This one No, but we'd like to call them. We've got a zippy and bungle on some sites.
There you go. You see,
yeah.
people like to name their
I
robots.
love them. We've got Delboy and Rodney in other sites. We've got everyone gives them a name. Everyone gives them a name. So this is a mobile robots. This is designed for pallet transportation. So this is from Mir. Mir and Universal Robots are the same company now in the background. So we're their biggest distributor. And we're Universal Robots' biggest global distributor.
And this finds its way around the factory floor, is that right?
Exactly. So we give it a map of the area, and the robot will then make its own decision of how to get to A to B, whilst complying with all of the safety regulations. And then within a map, we just zone off areas where it can't go into. Like we give it a forbidden zone. We tell it ways that it can go, ways that it can't go, and then we can trigger a command to it via a robot or via a human can give it a task. And then it will just carry out that task, automatically make its decisions of how to get there. It'll go around objects to get to its destination. If it's blocked, it'll turn around, find an alternative way to get there. So they really make a real flexible system to put in place for moving any internal logistics.
This is what I've learned. This kind of comes from robot vacuum cleaners, I think, and robot lawnmowers as well. They find their way around messy living rooms, don't they?
Same kind of tech, just on an industrial scale. We have to then look at how it's safe around a human, because this can weigh 300 kg on its own.
Yeah, you're not going to get mown down by your robo vacuum, but
exactly.
this, yeah.
No, and then we can move like 1.5 tons on this, so it's moving a lot, so it has to fully compliant with safety. But we can move stuff on here at nearly 2 meters a second, so we can really move stuff quickly.
Okay, honest answer now. Have you ever sat on it and been for a ride?
We have. I've got pictures of my colleague Alec over here sitting and eating his lunch on it whilst it's spinning around. Yeah, but they're not for public consumption.
All right, you know that this is going out live at the show.
That's fine.
All right, thanks for your time.